Hello, welcome to my channel. In today's lesson, we are going to be looking at what surds are and the rules that govern the operations of surds. First off, we will look at the meaning of surds. What are surds? Surds are simply numbers that does not simplify to give you a whole number. The square root of numbers that doesn't simplify to give you whole numbers. For instance, you can have, if you have root 2, square root of 4, square root of 6, square root of 9, square root of 16, and square root of 17. Of these 6 numbers, we can see clearly that the square root of 4 will give us 2. So therefore, square root of 4 cannot be considered a surd. It's not a surd. Now, again, if you look at the square root of 9, the square root of 9 will simplify to give you 3. So therefore, square root of 9 is not a surd. Of course, the square root of 16 will give you 4. So therefore, square root of 4, root 16 is not a surd. Root 4 is not a surd. But the square root of 2 won't give you a whole number. So root 2 is considered a surd. Likewise, root 6, it's also a surd. Root 17, it's also a surd. Another example is root 3, that is a surd. We have another one, root 5, that is a surd. We have another one, root 19, that is a surd. So surds are simply irrational numbers, okay? Numbers whose square root does not give you a whole number, okay? Now, what are the rules that governs the operation of surds? Now, the very first one I would like us to look at is root a times root a is equal to a. This means that when a surd is multiplied by itself, the answer is just simply the number under the square root sign. Now, to verify this, to see that this is true, if we have a square root of 2 times square root of 2, that will give you 2. Now, this means this is also the same thing as square root of 2 times 2, and that means square root of 4. And of course, square root of 4 is 2. So the first law is root a times root a is a. Whenever a surd of the same value multiply itself, the answer is just simply the number under the root sign. Now, the second one I'd like us to consider is root a times root b is root a times root b is equal to root a times b. What does that mean? Or we can reverse it and write it like this in the reverse, that root a times b is the same thing as separate root of a times the root of b. Now, what does this mean? An example would be, if you have, for instance, 2 times root 2 times 3, this can be broken down as separate root of 2 times root 3. Okay? Now, we use this sometimes to simplify surds. You can have something like this, root 18. This can be simplified further as root 9 times 2, which is the same as 18. Then you can split it and have root 9 times root 2. Alright, of course, root 9 will give us, square root of 9 will give us 3. So this will be 3 root 2. Now, the third rule is this. Now, if you have the root of a divided by the root of b, this is also equivalent to saying root a divided by root b. Now, an example will be, if you have, for instance, root 12 divided by 1 to 1. Now, this can be simplified as separate root of 12 divided by separate root of 1, 2, 1. Now, if you look at it critically, you can see clearly that the square root of 1, 2, 1 is 11, because 11 times 11 is 121. So this can simplify further as root 12 divided by root 11. And of course, 12 can be broken down as 4 times 3. Then applying this law, we can then split it. This is over 11. We can then split it as separate root of 4, root 4 times separate root of 3 over 11. So, of course, square root of 4 is 2, and then that will be 2 times root 3 is 2 root 3. That is 2 root 3 over 11. So, that is law 3. Now, the fourth law is this. The fourth rule, interchangeably, you can see either rule or law. Now, the fourth rule is this. When you have a root c, for instance, plus or minus b root c, this is the same thing as we can factor out the root c into a plus or minus b. Okay? Now, this is an example will be, for instance, you have, let's take the positive case, you have 5 root 2 plus, say, 2 root 2. This can be written as you take out the root sign, that is root 2 into 5 plus 2. Alright, so that would be root 2 times 5 plus 2 is 7. Or you can write that interchangeably as 7 root 2. Okay, so that is the fourth law and an example to buttress it. It also holds for negative. Okay, now the fifth law is if you have root a divided by root b, for instance, that will be the same thing as a divided by root b times root b divided by root b. Of course, root b divided by root b is just 1. Okay, so we multiply it up. You see this whole expression here is 1. Root b divided by root b is 1. So we are just saying this multiplied by 1. It doesn't change the value. But we do this most times to be able to remove root sign from the denominator of the fraction. Now, if you multiply it up, a times root b, that will be a root b divided by root b times root b is b, according to the first law. Alright? So now, this is the fifth law. Then the very last one I would like us to consider is a situation where you have mixed surds at the denominator. So that rule is this. If you have a divided by b plus root c, for instance, that is the same thing as root a divided by b plus root c times the conjugate of the denominator, that is b minus root c divided by b minus root c. Now, when we have a mixed surd like this under the denominator of a fraction, to get rid of the surd at the denominator, we simply rationalize by the conjugate of the denominator. By the conjugate of the denominator, what that means is that the mixed surd here, okay, you just change the sign of the mixed surd, okay, from positive to negative. If it is negative, you change it to positive, but in this case, it is positive. So we multiply it by what? The conjugate of this expression will now be b minus root c. So we multiply this whole expression, which is this, by the conjugate of this denominator here, which is b minus root c. So when we do that, if you simplify that expression, you have root a times b root c. That will be a into b minus root c divided by this time this will give us this result to what we call difference of two squares. That is b. If you look at that, is b plus root c into b minus root c. Now this difference of two squares, that's confined into, in numerator is a into b minus root c divided by, this will be b squared minus b squared. You take the first one, b squared minus root c all squared. Now that will be a into b minus root c divided by, now b squared is b squared, that doesn't change, minus square root c all squared. This will get rid of the square root sign, so you just have simply c. Alright, so we do this most times. This is called rationalization. We do this most times to rationalize the denominator of a sodical expression. So I believe this has brought us to the end of this lesson. Do well to subscribe to my channel and click on the notification bell icon below so that you get notified each time I upload a video like this one. I'll catch you in the next one. Bye.